This video will show you how to calculate the driving force and interfacial energy using the property model calculator in the graphical mode of Thermo-Calc. In this example, we're interested in finding the driving force and interfacial energy of the carbide M23C6. The calculation is based on example number 12 of the examples that were included with your software. However, in this video, the example has been expanded to include 5 elements. If you are using the demo version of the software, see the original example. Beginning with Thermo-Calc 2017A, you can now access the examples from within your software in both the File and Help menus. To begin the calculation, click on the Property Model Calculator template from the home screen of Thermo-Calc. All the nodes we need for a property model calculation will appear in the project pane. Select the FE demo database and the elements iron, chromium, manganese, nickel, and carbon. Set chromium to 17, manganese to 1, nickel to 1.4, and carbon to 0.08. This automatically sets iron to 80.52. Our system is now defined, but before we complete the main calculation, we need to do a single equilibrium calculation to see which phases are present at 650 degrees. Right-click on the system definer, highlight Create New Successor, and select Equilibrium Calculator. Change the temperature to 650 degrees Celsius. Notice that the system propagated down from the system definer. Our calculation is set, so right-click on Equilibrium Calculator 1, highlight Create New Successor, and select Table Renderer. Right-click on the Table Renderer node and select Perform Now. Once the calculation is complete, your table will appear in the results pane. We can see that there are 2 phases present. BCCA2 makes up most of the system, and M23C6, the carbide we are focusing on, makes up the rest of it. Remember these 2 phases because we will use them in our main calculation. We are now done with our equilibrium calculation, so click on the Property Model Calculator. Select the driving force and interfacial energy models and set the temperature to 650 degrees Celsius. Notice that the composition propagated down here as well. Select the Driving Force tab and set the matrix phase to BCCA2 because that is the phase that makes up most of the alloy at 650 degrees, as we saw in the equilibrium calculation. Set the precipitation phase to M23C6 because this is the phase for which we are calculating the driving force. Now we must set the interfacial energy to the same specifications, so click on the Interfacial Energy tab and set the matrix phase to BCCA2 and the precipitation phase to M23C6. Now we will set the calculation type. This section will apply to both driving force and interfacial energy, so we only need to set it once. Leave the calculation type as grid. Set the first variable to mass percent chromium, set the minimum to 16, and the maximum to 19. We will accept the default value for the number of steps. Set the other quantity to mass percent manganese, set the minimum to 0.8, and the maximum to 1.2. In this calculation, we want to see how driving force and interfacial energy change as a function of these 2 variables. Our calculations are now configured, but we want to overlay the 2 calculations on top of one another in the plot, so click on the Plot Renderer 1 node. Here we can see that the first set of axis variables is set to driving force. We want to add interfacial energy, so click on the green plus sign to get a second axis group. Change the bottom variable to interfacial energy. Our calculation is now ready, so select Perform at the bottom center of the program. Once the calculation is complete, our plot will appear in the results pane. The default is a contour plot, and the key tells us that driving force is represented by the blue lines and interfacial energy is represented by the red lines. The values of each calculation are shown on the lines. This plot shows how the driving force and interfacial energy vary as chromium and manganese vary. You can also visualize this data as a heat map by changing the plot type to heat map. However, when you use a heat map, you can only show one calculation at a time, so we must deselect one of the calculations. To do this, we simply uncheck the box under one of the axis groups. I will uncheck the box under driving force and leave the box under interfacial energy checked. Then select Perform again. The plot now shows the interfacial energy represented in a heat map. The contour scale on the right gives you the values, and in this plot, high values are represented in red and low values are represented in blue. To get a clearer version of the heat map, we can increase the interpolation. The higher the values, the clearer the plot will be. I will change it to 100 by 100, then select Perform again. We now have a smoother plot with the same information, the interfacial energy of the carbide M23C6 as a function of chromium and manganese. We hope you found this video useful. We are constantly working to create new videos, so check back regularly at www.thermocalc.com.